Hello guys, welcome back to my YouTube channel. We are continuing our series of numerical problems of Irodov. In this video, we will be considering the second numerical problem of Irodov, that is a point traversed half the distance with velocity v0. The remaining part of the distance was covered with velocity v1 for half the time and with velocity v2 for other half of the time. Find the mean velocity of the point averaged over the whole time of motion. Now, for the whole time of motion, the velocities are different, v1, v0, v1 and v2. And we want to find out the mean velocity here. So, let us draw the picture of problem first. Let us consider we have a point and it has traveled a total distance d between these 2 points. This is the line and it is representing the distance between the points A and B, and this total distance is D. The point traversed half the distance with velocity v0. So let us put a point in midway between A and B, and the distance AC is d by 2. Now velocity for this distance AC is v0. Velocity for distance AC is v0. The remaining part of the distance was covered with velocity v1 for half the time and with velocity v2 for other half of the time. Now remaining part of the distance has been also covered with two different velocity, but in this case the distance is not half but time is half. So we will not put the point in midway between C and B, because the distance traveled with velocity v1 is different than the distance traveled with velocity v2. So can you guess where should we put the point here in between C and B? It will depend on the magnitude of v1 and v2. If magnitude of v1 is greater than v2, then the distance traveled with velocity v1 is greater than the distance traveled with velocity v2. So we should put the point here such that CD is greater than dB, where CD is the distance traveled with velocity v1 and dB is the distance traveled with velocity v2. If v1 is less than v2, then the picture will be like this. This is the total distance and this is the C midpoint, and this distance is d by 2. In this case, the distance traveled with velocity v1 is less than the distance traveled with velocity v2. So we should place the point here such that CD is less than dB. So this is the picture for the case v1 is greater than v2, and this is the picture when v1 is less than v2. For now, we are considering v1 is greater than v2. So we are taking this picture for considering the problem. You can also consider this case also. It will not affect the result, but for our convenience, we are taking this picture for the problem. Now, let us consider the time taken in traveling from C to B is T. Let us draw a time graph differently. The line in between C and B here is representing the total time taken in traveling from C to B, and let us say this time is T. Now, on this time graph, we will put the D point in midway between C and B, because the time taken in traveling from C to D is same as the time taken in traveling from D to B, which is T by 2. But for distance graph, this is distance graph. In this distance graph, we cannot put the point in midway between C and B, because distances are different. Now, to find out the mean velocity, we need the total distance and total time taken. So, total distance we have D, and total time we can also find out in terms of D, V1 and V2 and V0. So, let us find out this. For this, first we need the distance CD and dB. Now, velocity for distance CD is velocity for distance CD is V1. Time taken in traveling from C to D, T by 2. So, distance CD is V1 into T by 2. Similarly, we can find out the distance dB. Distance dB. Velocity for the distance dB is V2 and time taken in traveling from D to B is again T by 2. So, this distance is V2 into T by 2. Now, total distance is equal to AC plus CD plus dB. AC is simply D by 2 and CD is V1 into T by 2 and this is also V2 into T by 2. Also, total distance which we have considered is D. Also, total distance was D. So, it implies that D must be equal to D by 2 plus V1 into T by 2 plus V2 into T by 2. Here from here we will find out T in terms of D and V1 by V1 and V2. So, let us find out this D by 2 and this will be V1 into T by 2 plus V2 into T by 2. T by 2 can be taken common from right side. So, this will be V1 plus V2 into T by 2. D by 2. 2 se 2 cancel out. So, time T will be equal to D upon V1 plus V2. This is the time taken in traveling from C to B. Now, time taken in traveling from A to C is time taken in traveling from A to C is distance AC upon velocity for the section AC, that is V0. So, this will be D by 2 V0. Now, average velocity is total distance upon total time taken. Total distance upon total time taken. Total distance is D and total time taken is this time which has been taken in covering the distance C to B and this time. That is the time taken in traveling from A to C. So this is d by 2 V naught plus d upon V1 plus V2. So this will be the average velocity. On solving it, d and d will be taken outside from the denominator. 1 by 2 V naught plus 1 upon V1 plus V2. D will be cancelled out. On taking LCM, 2V naught and V1 plus V2, this will be the LCM and comes in numerator, and this will be V1 plus V2 into 2V naught. So this is the result for average velocity. Next problem we will solve in next video. Thank you.